Hello friends, welcome to Pericyclic Reactions Part 1. This question is from CSIR Net December 2013. The number of nodes present in the highest occupied molecular orbital of 135 hexatriene and its ground state is. In order to understand this question, we should know the structure for 135 hexatriene. We have 6 carbons and then alternate double bonds at the first position, the third position and the fifth position. Here we have H2, here we will have H, and here H, and here CH2. So we are having 6 carbons. So we will have 6 lobes. Okay, we'll have the 6 lobes in this case. Since there are 6 carbons, we have 6 lobes. Now when we draw the energy diagram, and at this point, which is the psi1 case, we will have 6 lobes. Okay, these are very important lobes that we need to understand. There are 6 lobes. The positive side will be on the same side. The positive lobes on the same side. In this case, the nodes are 0. In this case, the nodes will be 0. Now, when you consider psi2, in this case, we will have psi6 because there are 6 carbon atoms, and lobes also 6 because there are 6 carbon atoms. In psi2, what will happen? We'll draw 1, 3, 4, 5 and 6. The first 3, the positive will be the one phase, this phase on the same side, another 3 will be on the opposite side. These are the phases of the lobes. So what is happening after 3, we have a break here. So the phases are different here. So we have a break here. That means in this case we will have a node here. So node over here is 1. This point is the node. So what we have to understand that in psi1 we will have 2 electrons. So total in 135 hexatriene we will have 6 electrons that are delocalized. They will be in conjugation. So 2 electrons will be in psi1. So where are these 2 electrons moving? They are moving, since there are no node, they are moving throughout these carbon atoms. In this case, there are 2 electrons. Where are these 2 electrons moving? They are moving on this side and only on this side. They are not moving throughout. The next case is psi3. In the case of psi3, we'll draw the 6 lobes. 1, 2, 3, 4, 5, 6. So we have same phases here. Now there is a break over here and it goes down, 2 goes down, and then another break, it goes up. So in this case we have another node over here. So the phases will be, this is the wave I am drawing. So node over here, it is 2. So what we have to remember, we have 6 electrons, so another 2 electrons will come here. So total 6 electrons are done. In this case, what is happening? There is no node. In psi2, we have one node over here. It breaks, there's a break in the phases. And in this case, it will be 2 nodes. Nodes are over here. The next case will be psi4. In psi4, we'll have 1, 2, 3, 4, 5 and 6. So just draw it in the neat way. So here it was 6 on the same side, upper half of it on the same side, and then 3 becomes 2 and 2 will become 1 here. So 1, and then we'll have 2 different phases. It goes up 2 different phases and then 1. So how many nodes here? Same phase, different here. So one node here, same phase, no problem. This negative and positive here, so it is a node here and then a node here. So 1 2 3, so n equals to 3 over here. So the wave will be like this. In psi 5 we have to draw the lobes. So here it was 1, which will remain constant, and then we'll have one lobe. Now it was here, so it will be here, here. In this way we are having different phases, so node will come here. We are having different phases here, node will come here, same phases, so no node here, no node over here. Different phases, a node here, different phases, a node here. So it will be one node, second, the third and the fourth node, so n will be 4. In psi 6 is highly unsymmetrical. It will be 6. I have drawn extra, I'll remove it. So it will be this side, this side, this side. All the phases different, they have different phases, node at every place, and the wave will be like this. So n will be equals to 1 2 3 4 5, so it will be a 5 node. In the ground state, this is the highest occupied molecular orbital. This is the highest occupied molecular orbital, and the node over here, it is 2. So the answer for that question was node is 2. Now what will happen if you excite this molecule? So what will happen? One electron from here, it will go to the psi 4. Now in excited state, I'm talking about excited state. In excited state, this is the new HOMO, that is highest occupied molecular orbital. I'm talking about excited state. Ground state, node is 2. If they are asking about excited state, psi 4 is the new HOMO, and here it will be 1 2 and 3 node. So the node in the case of excited state will be 3 nodes. In the case of ground state, this is the HOMO, and it will be n equals to 2.